In the name of God. Hello, dear students. Welcome back to Fairhouse website. It's me, Masood. I'm a physics teacher. In previous lesson, I finished chapter 1 for you. We explained all sections of chapter 1. And we reached chapter review and assess, page 26. We want to solve and answer the problem and questions with you. I want you to be with us to, to discuss these problem and questions. Question number 1. How many degrees equal pi radians? How many revolutions equal pi, radians? What does it mean? So this question is a two-in-one question. So as if we have two questions in one question. The first part is one question and the second one is another question. Let me, solve the problem for you. Actually, delta theta is given in pi radian. First of all, we want to find the delta theta in degrees. We have a rule for this purpose. Delta theta in degrees is equal to 180 divided by pi multiplied by delta theta in radian. So why did we invert the fraction? Because we need degrees. Whenever you need degrees, you have to use this fraction, 180 divided by pi, multiplied by the given. And the given in Israel, I want you to substitute the value, and we can simplify pi with pi. The answer will be 180 degrees. Maybe most of the students know what the value of pi is directly without solving the problem, without using the rule, because it's very common. Pi, is equal to 118 degrees. Maybe you don't use the rule and you memorize the value of pi in degree, and if you use the rule, no problem, it doesn't matter. The second part of the question, we need delta theta in revolution, right? How many revolutions, does 1 pi emit? Let's solve it the second part. Delta theta in rev is equal to delta theta in rad divided by 2 pi, right? And whenever you want to need, whenever you need delta theta or the angular displacement in rev, you have to divide the angle in pi in radian by 2 pi. So right now we have this angular displacement in radian, just divided by 2 pi to solve the problem, to get the angular displacement in rev, right? It's very easy. That's why pi divided by 2 pi. We can simplify pi with pi, and the answer will be 1/2 rev or 0.5 rev. Let's move on to question number 2, the second question. Distinguish between linear speed and angular speed. So we want to distinguish between linear speed and angular speed. I prepared the table for you for distinguishing this problem, this question. Question number 2, distinguish between two things. We have two quantities. One quantity is linear speed, or v small. Another one, angular speed, or omega. So what's linear speed? I'm sure you know about the linear speed because it's a background for us. It's not new information for us. In grade 11 especially, we got a lot of information about linear speed. But angular speed is new for us. Only grade 12, we studied this subject, angular speed. But by the finishing of this chapter, actually, I told you at the beginning of the lesson, I told you we finished the explanation, and I'm sure you know a lot of information about angular speed. It's very easy. You can distinguish between these quantities. First of all, by defining each, let's say, quantity, and the second difference, just mention the unit of either, right? Let's move on to the left part, actually, for the table, which is dedicated for linear speed. Linear speed, or V, is the distance traveled in a specific time interval. That's it. Distance traveled in a specific time interval. What do you say about angular speed, or omega? Is the time rate of change of angular displacement. Time rate of change of angular displacement. Linear speed, or V, is expressed in meter per second because it's a linear quantity. It's a linear quantity. It's expressed in meter per second, but angular speed, or omega, is expressed in rad per second. That's it. Question number 3. When a wheel rotates about a fixed axis, do all points on the wheel have the same angular speed or not? Is it possible for each point on the, let's say, on the wheel to have the same angular speed? Of course. I told you, and I focused on this one, and I emphasized this information. Keep in mind that angular information remains constant. Angular information remains constant. Teacher, what are the angular information? Let me jog your memory. Delta theta, right? Delta theta, omega, and alpha. And delta theta, omega, and alpha remain unchanged because they are angular information. So it says, when a wheel rotates about a fixed axis, do all points on the wheel have the same angular speed? Yes, they have the same angular speed. Actually, they have the same angular displacement. They have the same angular, let's say, angular acceleration as well, right? Let's read the question. Let's read the answer. It says, yes, otherwise its shape changes. And I told you about the subject in detail, especially at the beginning of the chapter. I told you about this one. If omega, or one angular information of the wheel of any rotating object, any, let's say, spinning object, if any angular information differs from one point to another, in this situation, a dangerous situation maybe is taking place. The shape of the machine changes in this situation. So what's this phenomenon actually happened? Because of the difference in the value of these angular displacements. So angular displacement should be, let's say, should be equal. Otherwise, the shape of the object changes. Otherwise, the object loses its rigidity. Right? Question number 4. A car on a Ferris wheel has an angular displacement of this number, 0.34, let's say, radian. What's this? This is delta theta. If the car moves through an arc length of 12 meters, what's this? This is delta S. What is the radius of the Ferris wheel? So we look for R. We look for radius of the wheel. So information available? Yes, everything is available for finding the radius of the Ferris wheel. Delta theta is given in radian, and delta S is given in meters. We look for R. Just rearrange the main equation for finding R, and R is equal to delta S over delta theta 12 divided by 0.34 becomes approximately 35.3 meters. This is the radius of Ferris wheel. Let's move on to question number 5. Let me read the question, and by the way, this one is a problem as well. When a wheel is rotated through an angle of 35 degrees, right? This is the first angular displacement, delta theta. A point on the circumference means on the rim of the wheel or tire, right? And the circumference travels through an arc length of this number, right? So this is delta S. Delta S for this angle, or this angular displacement. When the wheel is rotated through an angle of 35 rad and 35 rev, so we have three different values of angular displacement. We have to separate them just by let's say putting a subscript for each. Actually, this one is delta theta 1, 35 rad becomes delta theta 2, and 35 rev becomes delta theta number 3. And by the way, we have to let's say number the delta S as well, because for each angular displacement there's its own angular there's its own actually arc length. So this arc length delta S1 is actually dedicated for delta theta 1. The same point travels through an arc length of this number. What's this? This is delta S2, right? This number, delta S2, has to do with delta theta 2. What do you say about the third number, 9 times 10 to the power 2 meters, and is equal to 900 meters? We can say 900 meters, or you can use it as it is without any changing. So they are the same. 9 times 10 to the power 2 and 900 are corresponded to one another. They are equivalent, respectively. And I have a question for you. This delta S has to do with which, let's say, angular displacement. This delta theta, delta S3, is related to the delta theta 3. So we have 3 angular displacement versus 3 arc length. Let's say, separate them and I summarize them here in this box. For example, delta theta 1, 35 degree. Let's say its corresponding arc length is delta S1, which is equal to 2.5 meters. Delta theta 2, 35 rad. Its corresponding arc length is equal to 143 meters. And the third one, 35 rev. This is the angular displacement. What's its corresponding arc length for this angular displacement? 900 meters. I converted 9 times 10 to the power 2 to 900, as you like. If you are not satisfied with this number, you can use the, let's say, scientific notation, no problem, as you like. 9 times 10 to the 2 meters or 900 meters. They are the same. Let me tell you a note here, because there is one wheel, right? There's one wheel. And the wheel, let's say, over time, it changes the angular displacement and it changes its arc length. And for each, and you know, there's one wheel only. These information are dedicated for what? They are dedicated only for one wheel. And you know that the radius of one wheel is constant. Because you talk about one wheel, the question talks about one wheel. That's why the wheel has only one radius. whether the angular displacement changes or not. So you get the same number for each case. We have three cases. We have three questions in one question. We have three in one. And for each case, for example, for this one, I want you to find R, right? You get a number, whatever number. You get the number. What do you say about this one? You have to find R for this part, for this case actually, and you get the same number as the previous case. About the third one, you have to find R for these information, right? And you have to get the same previous information. So what do we, let's say, what shall we do in this case, right? What shall we do? Either you focus on only one, let's say, one case. You focus on one case. If you find R, it does need to find, let's say, R for other cases because there's one wheel and the radius of wheel does not change. Whether the wheel, let's say, speeds up or slows down, it doesn't matter. Radius remains constant and unchanged, right? So, or you can say, maybe you say, teacher, I'm gonna, let's say, I'm gonna focus on all parts of this question, let's say, to make sure that the answer, let's say, to make sure that we get only one answer, no problem, as you like. You can say R is equal to delta S1 over delta theta 1, delta S2 over delta theta 2, delta S3 divided by delta theta 3. I told you, whenever you focus only on one case, you are right. You find the answer. And it doesn't need to try other, let's say, other cases. But here, let's say, I'll solve the three parts actually, but in one equation. In one equation, because R, you see, I didn't put any subscript for R because R remains unchanged for each case. I told you whether the wheel, let's say, whether the wheel speeds up or slows down, it doesn't matter. R remains constant. That's why we cannot number it as R1 or R2, R3. Only we have one R. Right. So about the first one, information is not, let's say, unified. We have to unify information. Degree is not allowed in SI. You have to convert it into the what? Into the rad. About delta S1, we don't have any problem. Right, 2.5 meters divided by 35 degree. 35 degree, whenever you multiply it by this fraction, it converts to the radian directly, is equal to 100, the second part of the question. 143 divided by 35. And in this case, we don't have any conversion. Write it as it is. The third part, delta S3, 900 divided by 35 rev. I told you in previous lessons, whenever you encounter rev, whenever you observe rev, automatically, without thinking, substitute 2 pi instead of rev. So in this case, it's converted to what? It's converted to rev as well. And in either case, I told you, only we have one number, and it indicates, this constant number indicates that the radius of the wheel remains unchanged, whether the wheel slows down or it speeds up, it doesn't matter. This is question number 5. Let's move on to question number 6. Question number 6, and it's only it's a problem, and this problem actually is the question of national exam. I mentioned it here. I have seen this question in a national exam over and over again, right? Let's read it for you. It says, how long does it take the second hand of a clock to move through 4 rad? How long does it take? Whenever you hear this phrase, actually, this term, how long, right? How long means it talks about delta t, right? Time interval. How long does it take the second hand? Actually, any clock has three hands or needles. The first, the shortest needle or shortest hand is called hour hand, right? We have the medium in length, actually, medium, let's say, hand is called, uh, the medium hand is called minute hand, and the longest one is called, let's say, second hand. Here it says, how long does it take the second hand of the clock to move through 4 rad? First of all, I want you to ignore this information, right? Don't care about 4 rad, as if there is no this information in our question. Focus on a clock, right? Focus on a clock and find omega for the clock. For any clock or for any, let's say, watch, there's a constant omega for each hand, let's say, for second hand, for minute hand, or for hour hand. The omega for each case actually is constant for each clock all over the world. For example, because here it says second hand, that's why I only focus on the second hand of the clock, right? This is second hand. I have a question for you. How long does it take the second hand to complete one full cycle from 12 o'clock till 12 o'clock? How long does it take the second hand? How many seconds does the hand actually take, right? Of course, I'm sure you know the answer, because delta t is equal to 60 seconds, or we can say 1 minute, or 60 seconds. So this information is constant for all clocks and watches all over the world. What do you say about the delta theta? I told you during my question, I said, how long does it take the second hand of a clock to complete one full cycle? I said one full cycle or one revolution. So delta theta is 1 rev. So 2 information are available. By means of delta theta and delta t, we can find omega for the clock, and it's constant, right? You see that we ignored the information within the question. We didn't care about 4 radian. We focused on the clock, right? We deduced the delta t and delta theta, and by these information we can find omega. Let's say, solved it here. Actually, omega for clock. This is the let's say common rule of omega: delta theta divided by delta t. Delta theta becomes negative 1 rev. Why did I let's say put negative? Because it's clockwise, right? It's clockwise. Negative divided by delta t becomes 1 minute. So time period for second hand of the clock is 1 minute, or 60 seconds. You can say 60 seconds. You can start from here, no problem. You can start from the second step, no problem, as you like. Negative 2 pi, because 1 rev becomes negative 2 pi divided by 60, becomes negative pi divided by 30 rad per second. If you can memorize this number, it doesn't need to write this, let's say, rule at all. If you memorize the number negative pi over 30, if you convert it to the decimal fraction, as you like, no problem. If you substitute 3.14 here and divide by 30, you find this number, negative 0.105 rad per second. Either you memorize this one or this form, no problem, it doesn't matter. So if you memorize omega, this omega, negative pi over 30, or negative 0.105 rad per second, it's constant. It doesn't change for second hand. This is dedicated only for second hand. So you can, let's say, you can eliminate the rule. You can start from this one, this value. If you memorize it, if you memorized it, actually, you can save the time by this memorizing. And we look for what. Right now, let's say I come back to the question, to the given of the question, and unknown. It says, find the delta t. How long does it take? How long does it take for each purpose? For let's say for the second hand of the clock to take 4 rad, yeah, for travel 4 rad. So we have 4 rad. This is delta theta. We look for delta t. We found omega already. That's why just divide this number 4 divided by this. Why did I put negative here only always for let's say this part? Because it talks about the clock, and clockwise direction means negative. So negative 4 divided by negative 0.105, or instead of this number, this value, you can write negative pi over 30, no problem, as you like. So the answer approximately 38.1 second for this value. If you put this number pi over 30, you find 38.2 exactly. So there's a 1 point difference between the answers, right? And this is the answer, 38.1 or 38.2. I told you this question is a question of final exam, right? So in final exam, I took the options from this, from one of these, let's say, exams. What are the, let's say, options? The option A is 38.2 second, B 20.2 second, C 10.2 second, D 8.2 second. So and our answer was 38.1 second. So approximately I can say this value is very close to the A. That's why you can circle A here, right? So sometimes in our solution, in our calculation, whenever you solve a problem, maybe you don't get the exact number of the option, no problem. Choose the nearest value. Here, 38, we got 38.1, but in the options, we don't have 38.1 at all. But we have a very close value for 38.1, which is 38.2. That's why I choose this one, because other values are, let's say, are away, right? Are far away from the delta t. That's why from our value. That's why we didn't choose the other values. So I wrote some tips for you. I prepared some tips for you about the second hand, minute hand, or let's say hour hand of any clock. In the national exam, only I have seen, let's say, this form of questions, second hand. But let's say for, let's say, we want to, let's say, get more information about the, let's say, other cases of the clock. Maybe, let's say, this year or in, let's say, next year's actually next exam, we encounter this, let's say, this situation. That's why I prepared, let's say, 3 notes for you for better understanding the subject and recognizing the case. Let me read the tips for you, and after that, we finish this lesson by reading these tips. Some tips about the, let's say, have to do with the question number 6, right? Some tips have to do with what? Have to do with clock. The first one rev takes 60 seconds for second hand. So for second hand, 1 revolution takes 60 seconds. Second hand, 60 seconds. This is delta t, right? Delta t, we have delta t becomes 60 seconds, and this one delta theta, right? I solved the similar question for this, right? What do you say about the second one? And I told you I haven't seen these cases in national exam questions, but I admit them, I included them into my pamphlet. Number 2, one rev takes 60 minutes for minute hand. You see, 60 minutes for minute hand. So minute hand takes 60 minutes to travel one full cycle, right? And if you, let's say, take a look at the value, at this value, one rev, one rev, one rev. So revolution or delta theta in delta theta is constant, right? Whether you have second hand or clock hand or minute hand, it doesn't matter. So delta theta is one rev only. But delta t changes. Delta t for second hand takes 60 seconds. For minute hand takes 60 minutes. For hour hand takes 12 hours. That's it. Right. For example, about the second case, we want to, and you know this information, in SI, System International of Units, let's say we are not allowed to use minute for time interval. You have to convert it to the second. How do you convert minute to second? By let's say by multiplying this value 60 by 60, and you get 3600 seconds or 3600 seconds. This is the time interval. For which purpose? Interval for which one? For the minute hand, to take the one full cycle. What do you say about the hour hand? One revolution takes 12 hours for hour hand, and you know hour is not allowed in SI. You have to convert it to second. How do you convert it to second? Firstly, you have to convert it to minute. How many minutes, let's say, does 1 hour admit? Right? 60 minutes. So whenever you multiply 12 hour by 60, you converted hour to minute, but it's not our, let's say, our result. It's not our, let's say, conclusion. We want to have time interval in second. After that, you have to convert, you have to multiply, let's say, multiply it by one more 60. So 12 multiplied by 60 multiplied by 60, you get this number 43,200, let's say, second. This is the time interval for our hand to take to travel one full cycle. I'm gonna, let's say, finish this lesson here. Thank you very much for watching this video, and bye for now.